Okie dokie. Okie dokie. Do you have a spare pen or pencil, Matt, I can borrow? I left mine in the office. Anything, yeah. Super duper, thank you. Okay. Alright guys, so we start the tutorial now. We'll look at the answers for electric field potentials. Oh, it's doing that thing again. Whoa! There we go. Alright. Thank you. Okay, question 1 was convert 2.5 electron volts into joules. So how did you do this? What do we need to do to convert that? How do we make electron volts into joules? Times the E, isn't it? So, did you get this answer?
Yeah.
4 times 10 to the minus 19 joules. Okay, next. How do you convert 1.5 nanojoules into electron volts? Don't be shy, guys. Also, don't be tired. How do we do that? We divide. Let's see. That's a bit big. 9.36 giga electron volts.
Sorry, we declare a bit of E.
Yeah. Is that okay? I'm not feeling the energy this morning. No energy off you. Number 3. What is the potential energy of a proton which is equal distance between 2 parallel plates, separated distance of a millimeter, and a potential of 9 volts? Okay, so you have 2 plates, and this here is 1 millimeter, and the proton is in the middle here, and we want to know what's its potential energy. So what's the formula for potential energy? It's mgh if it's gravity, and if it's in an electric field, Q Vd. But the D is not 1 millimeter. I was trying to trick you a little bit. What's the D here? Did you use 1 millimeter?
Is it always
QV what?
QE?
Oh, sorry, I wrote QV. Sorry, QE. You're right. QED. Yeah. What's the Q? The Q is E. What's the formula for E? V over D for this E. Yeah. What did I say the V was in number 3? 12. No, 9. Yeah? Yeah. What's the D? A millimeter. What's the D here? This D is the height of the proton, not 1 millimeter. So I was trying to confuse you a little bit here. I got you, did I? 10 minus 3. Okay. Let's see what we get there. Pretty small. 7. Oh, and I said I want the answer in electron volts. So divide by E. So 4.5 electron volts. Continue? You got that? Okay. 4. How fast would an electron be travelling if it leaves a negative plate, positive plate, electron travels down. This is 2 centimeters and 12 volts. How fast would it be going? Okay, so what we say is the potential energy here equals the kinetic energy here. So potential energy is QED, or also you could use the formula, what's the other formula we had? QV, if you want, you get the same answer if it starts here. And that should equal a half mv squared. So the V will be 2QV over m square root. So it's an electron, so that's square root. The V is 12, so that's 24E over the mass of an electron. Right, let's see what we get for our answer here. Square root 24E over mass of an electron. So that's pretty fast. Let's put in kilometers per second. 2055 kilometers per second. Got that? Yeah, continue. Okay, hang on, let me just write something down. Alright, 5. How long would it take a proton to travel from positive plate to negative one if they're a millimeter apart and it's 25 volts? So this is 25 volts and it's a millimeter apart and the proton travels like this. Okay. So this is a UVATS problem. We need to think about what we know. Do we know the U? Yes. Do we know the V? No. Do we know the A? No. Do we know the T? No. Do we know the S? We do. Now just keep it easy. I'll just say down is positive. So that's 10 to the minus 3. So we need one more piece of information. If you look at these 3 things here, what do you think would be the easiest one to work out? What do you think? What could we work out between V, A and T? What could we calculate? Think about the last example.
PE equals K.
Yeah. If we use the PE equals KE, what could we get from that? We could get V. We can say QV equals a half mv squared. So again, we can say V is square root 2QV over m. So this one would be square root 2 times, what's 25? So 50 E over mass of the proton. Let's calculate that. (50 E over mass of proton). Did I? Thank you. Right, so that's 69206. But that's not what I wanted. What did I want? I wanted the time. So what's the easiest way to get the T here? V equal, no. S equals? Yeah, S equals UT plus a half AT squared because the U is 0. So the T would be 2S over, oh no, we don't know the A, that's not going to work. So what form do I have left? S equals U plus V, that one. S equals U plus V over 2 times T, and the U is 0. So T is 2S over V. Great. 2s over v. Tiny. Oh, it's getting worse. Ten to the minus 8. 28.9 microseconds. No. Nanoseconds. Yeah, nanoseconds. 28.9 nanoseconds.
So,
Yeah.
I got the B
Good.
is 69201.
Yeah, that's okay for the exam. They only care that you got 692. Continue. See, but do you need a minute? You're okay? Right, the last one for this one is electric plates. We have a particle here. It moves through the plates and it just about gets out at the end. The distance here, what is it? 5 centimeters. The length here, 10 centimeters. What else do we know? It's 9 volts. And here, it's going at 0.01 c, speed of light. Okay, I've got all my info. First question, what is the potential difference between the plates? Why the heck did I ask you that? You know what it is, it's 9 volts. So that was kind of a stupid question. So the first one is 9 volts. Why did I ask you that? I say it in the question. Sorry, I don't know why I did that. Okay, B. By using conservation of energy, you know what? I must have meant to ask you what is the electric field between the plates. So I'm going to calculate that, the electric field. The E, not the potential difference. Okay, so how do you calculate the E here? How do you calculate the E? It's voltage over distance. So this one here will be 9 over 0.05. Is that 180? Yeah? Okay, and the unit volts per meter, well, what was the other one? Newtons per coulomb, yeah. Okay. Now, part B. By using conservation of energy, calculate the final speed of the particle. Okay. So tell me, what type of energy does it have at the beginning when it's here? Potential, certainly, and kinetic, because it's moving. So the potential is Q E D plus a half u squared, the speed at the beginning. That should equal, now what energy does it have here? Only kinetic actually, because it's at the bottom, it's hit the plate, so, well, it's no height. So a half v squared. Okay. So I want to work out the v here. So what I'll do is I'll multiply by 2, and that's gone. And I'll divide by the mass. And finally I'll square root. So if I hit this in on the calculator, I can get the v at the end. So let me show you what we're typing in. Watch carefully. Square root. 2 it's a proton, so its charge is E, times E, which we said is 180, times D, which is 0.025, plus, oh, it's not proton, it's electron. Mass of the proton times speed squared, which is 0.01 c. What constant is c on this calculator? It's like 20 something. Does anyone have the lid? C0? 28? Thank you. Over mass of proton, which is constant number 1. Okay, so I have all the numbers typed in and square root. The V, yeah? Oh, sorry, I keep. Oh, thank you, Matt. Electron. Thank you. Oh, and then that means up here is wrong. Sorry. Mass of electron. Okay, we're all good now? Yeah. Okay. So, 3251229 is the V here. 3251229 meters per second. Can I continue? Yeah? Can I do the last part? Now, lastly, here's the plate. Here's the electron leaving the field. The field was here. We've just worked out it's leaving at a speed of 3251229. This speed is made up of a horizontal and a vertical component. We actually know one of these. Can anyone tell me which of these blue ones we know and why? Does anybody know which of the two blue ones we know? Why is that? Yeah. Right answer. Okay, reason. The horizontal is still 0.01 c. Why? This should remind you of projectiles. In this picture, the force is acting down towards the plate. This is a lot like gravity pulling something down, isn't it? We know from the projectile lesson in mechanics that the axes are independent. So this horizontal speed doesn't actually change. So at the end it's still doing this. Now if I draw my triangle here, we know the hypotenuse and we know the horizontal one here, and I want this angle. So I need to use, which is it, sine, cos or tan, which has hypotenuse and adjacent in it. Which one's that? That's cos, isn't it? So theta is cos inverse c over 3251229. So let me put that in on the calculator. Shift cos inverse, shift 7. What did you say C0 was? 28? Yeah, over my answer. Math error. Maybe it can't handle the big numbers. Huh? Let me try again. I believe you, but I want to know why my calculator's not cooperating. Why? Is it in ratings? Maybe this number is wrong. It's actually too small. Let me go back to that calculation. 2, correct. E, correct. 180, correct. 0.025, correct. Mass of electron, correct. 0.01 squared, correct. Mass of electron, correct. 3251229. Cos is adjacent. Oh! What did I forget to write here? 0.01. I never put in my 0.01. Okay, thank you. Alright, so I should have had 0.01 here on the top. Right, and then cos inverse. Yeah, thanks, Matt. 22.8 degrees. I have bad news. That was an exam question. Okay. Can we go on to magnetic fields? Yeah?